Hi, I'm
Hi, I'm Troy.
Hi, I'm Vincent.
and we are part of the linear algebra group. So our plan is to break down the project into sprints. Our first sprint will be to develop a simple multiplication of a 2 by 2 matrix. After that, we will implement matrix addition and subtraction of the same square 2 by 2 matrix. Then we will implement dot product for that 2 by 2 matrix, and finally vector operations. If we are given more time and resources, then we will also implement operations for larger matrices. A couple assumptions that we're going to use are we are going to assume that there will be only two matrices as inputs, and for our testing we will populate with default values. Any changes will be done in the .data section or by file input output. So for the operation of two matrices, A times B, we have four potential approaches. The first one is, in order to simplify multiplication, we will first store B as B prime, a shifted matrix, and then we can do multiplication on the array.
Another potential approach is approach B, which, in order to simplify multiplication operations even more, will first store B as a list in the stack, such that each number is stored in the stack in the position that it is in the matrix, and then operations will be performed simply by referencing each position in the stack rather than pushing and popping. Another potential approach is approach C, which is rather than attempt to transpose matrix B into B prime, we will simply store B prime. B will not be stored in memory, but its equivalent may be outputted. So that the difference between this approach C and approach A is that under approach C, you're not even going to store B as B. All you will store is B prime.
Another way, number D, we have to store the input matrices as lists. Each matrix will have one storage location for data and another for dimensions, meaning there will be four input value lists. This is so that we can have easy access to all the different values stored in the input matrices easily. Other operations would follow the same memory strategy as above.
So some potential difficulties that we're considering. One is that we're going to have to determine which operation should be performed based on input. So whether that is subtracting or adding or multiplying or dividing, we are going to have to read those values from input. Another potential difficulty is performing operations on different size matrices. So we're starting out by working with 2 by 2 matrices, but we might work with larger matrices such as 3 by 3 matrices, and we could work with non-square matrices as well, such as a 1 by 2 or a 1 by 3. Other potential difficulties are error handling in cases of attempts to multiply invalid matrix sizes. So you need to have the same number of rows and columns that you are multiplying. So we will have to come up with some sort of error handling method if there are invalid matrices entered or invalid operations on matrices. And then we also need to figure out how to do risk unit testing in RISC-V to make sure that our application will work for other inputs.
The selected approach and rationale. We're using method D as it is obviously superior to the others in every facet. From formatting and reliability to data accessibility and readability, it's good.
Thank you for that, Vincent. Now, take a look at our API, the methods that we've laid out. Firstly, we have the method loop through the string. This is the method that will go through the data input string. Next, we have our selector method, which will select the proper element from the array on which to perform operations. Our next method is matrix add. This would add one matrix to another matrix. For example, matrix A would be added to matrix B.
We'll also have matrix subtract, which will subtract from another, i.e. A minus B. We also might have matrix rotate, which will transpose a matrix, i.e. A to A prime. Matrix multiply will multiply two matrices. Dot product will calculate the dot product. And we'll need helper methods for these, including malloc, which will allocate memory for the stack based on the given matrix. Length, which will return the length or the number of elements in the matrix. Convert to int, which will convert the dot data input into integers. Create stack, which will make a stack. And finally, store results, which will store the results of the linear algebraic function. So that way we can print it using print line and printf.
So that is an overview of the plan for our project. Please let us know if you have any feedback or insights that would be helpful to us. Otherwise, this is us signing out. Thank you and have a wonderful day.